Welcome back to the lecture of time series econometrics. In this lecture, we are going to talk about the stationarity property of the random walk models. Now, if you remember, there are certain conditions which are required to be fulfilled for a time series to be stationary. And we mentioned about three such conditions. One was that the mean the mean value of the time series should be equal to some constant, right? And which is not a basically not a function of time. Okay. Similarly, the variance should be some constant which is not a function of time, right? And the third condition we said, and the third it's not a function of time. And the third condition we said is that the covariance between two values in the time series yt yt plus s is not dependent on t. It is dependent on the lag, but it is not dependent on say t. So it might, I can write something like this. It's s, it is dependent on s but not a function of time. Okay, now these conditions, so let me write it down: 1 2 3. Now we can actually, using these properties of stationary series, we can actually say that the stationary could be explained in terms of mean stationary and variance stationary. Let me write it down. So if the condition, the first condition is fulfilled, the first condition is fulfilled, mean, we call it mean stationary. If the first condition is fulfilled, we call it mean stationary. Let me actually draw a diagram of a mean stationary process. Say, so if suppose I have something like this, where my variance is constant, but my mean is not. So this is not a mean stationary process. This is a variance stationary process. Whereas my series to be mean stationary, let me draw with a different color. If my series is a mean stationary, it will be something like this. Oops. It will be something like this. Okay. So there are differences. There are in different time period there are different values, but it is actually oscillating around a mean. Okay, so this is what is called a mean stationary. I can also have a series which will look like this. So it means that this is definitely not a constant variance time series, but it has a mean stationary. So it is constant around mean. Okay. Similarly, you can easily sort of figure out what it would mean to have a series which is a variance stationary series. Okay. So for a series to be variance stationary, it has to have a constant variance. So it can have mean stationarity or not, but the variance has to be constant. Let me use a different color. Uh, so it can either look like this, or it can look like, you can have different magnitude of variance, but as long as the variance is constant, we are fine. Okay, so this is again a variance stationary series, or the one we have shown previously, something with a mean non-stationarity but a variance stationary. We can have a process like this. Okay, so this is again a variance stationary process. Now with this, the reason actually we have given this idea of mean stationarity and variance stationarity is that when we had our random walk model, one was with drift and one was without drift, we have gotten different um, values of mean and variance. So let me just write it down. So let me write down, okay, let me write down here random walk model, random walk model. And I have two type of random walk model. One is with drift. First, let me write without drift. Without drift. And another was with drift. and I had two parameter. One was the mean. Let me write down. And the other was variance. And if you recall, the mean for the with drift process was the mean for the without drift process was 0. The expectation of yt was 0. To small 0, let me just make it big as 0. Okay. And whereas my variance was t sigma square. On the other hand, when I used mean with drift, I had my mean alpha t, alpha is the drift parameter, and I had the same variance t sigma square. Okay, so if this is how my mean and variance for these two different models look like, so how could I interpret about the stationarity? So let us look at the first the mean for the without drift model. So it is 0. So it is actually satisfying the condition that the mean of a stationary process is constant. So 0 is basically constant value, right? So I can say the random walk model without drift is basically a mean stationary process. Whereas a random walk model without drift, if I consider the variance, you see it is equal to t sigma square. So that means as the time is increasing, my variance is also increasing. So it would be something like this one, this one. So as your time is increasing, your variance is also increasing. So it is not really a variance stationary process. It is actually the variance is increasing, right? On the other hand, if I consider the random walk model with drift, I see the mean is equal to alpha t. My mean here is alpha t. Now, when I have a mean alpha t, that means with time my mean is increasing. So it is something like this one. Okay, this is something like this one, or probably this one. Okay, so with time my mean is increasing. So then this is not a mean stationary process. It could be variance stationary, but we can check the variance stationarity, and we see for variance stationarity we see it is something like t sigma square. So when I have a t sigma square, which means my variance is also increasing. So which is again something like this. Now, if I superimpose this mean non-stationarity and variance non-stationarity for with drift model, so I will have something like, if I want to draw it, I will have something like, let me draw it here. Something like, if I want to simplify this, okay, so it means it is both mean non-stationary and variance non-stationary. All right, so that's how we can actually interpret the stationarity for random walk model. Now a question that we have to answer here is that why a random walk model which is nothing but, which is basically created with white noise, and the white noise which are IID and which are basically stationary process. Now why this white noise which are stationary are creating this random walk model which are non-stationary? And to answer that, we will we'll basically try to answer that in the next lecture, and we'll talk about a technique called differencing. Okay, so thank you very much.